Coming to the problem number 12 is given. Construct the profile of a cam to suit the following specifications. Cam shaft diameter equals 40 mm. Least radius of cam equals 25 mm. Diameter of roller 25 mm. Angle of lift 120 degree. Angle of fall 150 degree. Lift of the faller equals 40 mm. Number of pauses are 2 of equal interval between motions. During the lift, the motion is SHM, that means simple harmonic motion. During the fall, the motion is uniform acceleration and deceleration, or we call it as uniform acceleration and retardation. The speed of the camshaft is uniform. The line of stroke of the faller is offset 12.5 mm from the center of the cam. So this is how the problem has been given. So let us go through this problem and let us see what we can make out of this. They have mentioned camshaft dia is 40 mm and the least radius of cam is 25 mm. Now, in the earlier problems that we have solved, we just had the least radius of the cam they would have given radius of the cam. But here they also mentioned cam shaft diameter that equals 40 mm. Now, among these two, which is the base circle, whether it is 40 mm or 25 mm? We should know how we define a base circle. We have defined earlier sessions base circle as the smallest circle that can be drawn to the cam profile. It is defined as the smallest circle that can be drawn to the cam profile. So here they clearly mention least radius. So least radius of the cam means it is the base circle. Okay, not camshaft diameter. So here the base circle will be least radius of cam, that equals 25 mm. Next they have mentioned diameter of roller as 25 mm. So as here the diameter of the roller has been mentioned, it means the type of roller, the type of follower is roller type. So we have solved problems where the follower was knife edge, then flat edge and roller type. Here is clearly given the diameter of the roller. So that means the type of follower is roller type. Then they have mentioned angle of lift. Here the angle of lift indicates the outstroke, that is 120 degree, and they also indicated angle of fall, that is the return stroke, that is 150 degree. And they mentioned lift of the follower equals 40 mm. Here lift of the follower is indicated by symbol S, that is 40 mm height. Now in the problem they mentioned the outstroke and the return stroke as lift and fall, but they are not mentioned dwell, right? They are not mentioned dwell, but instead they are given number of pauses are 2 of equal interval between motions. They are given the number of pauses. Pauses is nothing but dwell, and they are of 2 of equal interval between motion. That means after the outstroke or lift they say dwell, then the return stroke or angle of fall, after that again they say dwell. So it's clearly mentioned number of pauses are of 2 of equal interval between motions. Now we have to see what is that angle of dwell. Okay, they are not given the angle. We have to calculate what is the angle of the dwell between the motions. We know cam complete rotation equals 360 degree. In this 360 degree, they already mentioned the lift and the fall as 120 and 150 degree respectively. That means out of 360, you add these two, it comes to 270 degree. So out of 360 degree, we have 270 degree as lift and the fall. So the remaining will be dwell. So remaining is 90 degree. And the problem they mentioned 2 equal interval. That means 90 degree by 2 equals 45 degree. That means each dwell is 45 degree. So here we'll be having angle of lift 120 degree, dwell 45 degree, angle of fall 150 degree and dwell 45 degree. So that is how it will be. Again they mentioned during the lift, that is during the outstroke, the motion is simple harmonic motion, and during the fall, that is outstroke, it is uniform acceleration and retardation or deceleration. See, so for whatever problems we have solved, there the outstroke and the return stroke followed any one motion. Followed either it's a uniform velocity or simple harmonic motion or uniform acceleration retardation. But here in this particular problem, the follower follows the two motions, that is during the outstroke it is simple harmonic motion and in the return stroke it is uniform acceleration retardation. So that is important point that you have to make note of. Then they are given the speed of the cam is uniform, and also the line of the stroke of the follower is offset by 12.5 mm from the center of the cam. They have mentioned the offset, but clearly and also you should note here, they have not mentioned the direction of offset. As they have not mentioned the direction of the offset, we'll take it as on the right side. That means the follower is offset to the right side by 12.5 mm from the center of the cam. So that is what the problem is. So let us, whatever values they have given, using these values, let us draw the displacement diagram and the profile of the cam. So coming to the displacement diagram first, we know displacement diagram, the first thing we have to do is draw a horizontal line, and this horizontal line will represent the outstroke, dwell, return stroke and dwell as mentioned in the problem. Okay, so draw and whatever here the values that we are entering for outstroke, dwell, return and dwell, that will be done according to a scale. You take some suitable scale and write these values of 120 degree, 45, 150 and 45 degree. So first mark AS, that is the lift or what you call outstroke 120 degree, pause or dwell 45 degree, return stroke 1 or fall 150 degree, and finally the dwell or pause as 45 degree. Once it has been marked, divide the outstroke and the return stroke into equal number of even parts, say 6 as shown in the figure, and mark it as 1 dash 2 1 2 3 4 5 6 or and outstroke as 1 dash 2 dash 3 dash and so on. Once it has been divided, draw vertical lines through these points of 1 2 3 and also 1 dash 2 dash. As now the height of this vertical line will be equal to the lift of the follower that they mentioned in the problem, it is 40 mm. Then we complete the rectangle box. After that, as mentioned clearly in the problem, the lift or the outstroke has a simple harmonic motion. Now whenever there is a problem with simple harmonic motion, we have to draw a semicircle as shown here, and this semicircle again will be divided into equal number of even parts, same as that of lift or fall, that is 6. So after dividing it to 6 parts, mark it as A, B, C, D, E. Now from these points of A, B, C, D, draw horizontal lines. Here we can see that from A, when the horizontal line is drawn, it intersects the vertical line 1 at B. If again from point B, when you draw the horizontal line, it intersects the vertical line 2 at point C. Same way we get the points D, E, F, G. Now we have to join all these points with a smooth curve. So this is the displacement diagram during lift. Next we have the dwell, or where the follower is in stationary, so it's a straight line. Next, coming to the return stroke or fall. In the problem it has been clearly mentioned that the return stroke follows uniform acceleration and deceleration. So whenever we have a problem where uniform acceleration and deceleration is there, we have to take the midpoint. We have to take the midpoint of this outstroke. In this here, the midpoint is 3 dash. Take this point and take this vertical line. Now this vertical line 3 dash has to be divided into again equal number of even parts, 6 as we have taken for earlier. So divide this vertical line into 6 parts. Next, taking P as the center, draw the lines joining these points which we have divided, the line divided. Okay, now you can name it if you want it. Now from P, when you draw the line, it intersects 5 dash at N, again it intersects next line 4 dash at M, and again it intersects 3 dash at L. So join all these lines with a smooth curve. Next, you take H as the center and again join the lines to the midpoint where it is divided. Now when you draw the H, it intersects 1 dash at J. Again when you draw the line, it intersects 2 dash at K. Again if you draw H to 3 dash, it again intersects 3 dash at L. So again join this with a smooth curve. So this completes the displacement diagram during outstroke following uniform acceleration and deacceleration or retardation. Next we have the dwell, just draw a straight line. So this completes the displacement diagram, which this is a displacement diagram where the lift had a simple harmonic motion and the fall had a uniform acceleration deacceleration. Let us draw the profile of the cam. It's mentioned profile of the cam when the line of stroke of follower is offset by 12.5 mm from the center of the cam. So first take a center with O as a center, draw the base circle. We have to draw the base circle. So this is the base circle and it's given in the problem the value of the base circle, which is 25 mm. Once the base circle has been drawn, as this is a roller follower, we need to draw the pitch circle. So pitch circle will always be greater than the base circle. So to draw the pitch circle is the sum of radius of the base circle and radius of the roller follower. And the problem they mentioned roller follower is 20 mm. So radius will be 10 and the base circle radius is 25. So 25 plus 10 equals 35 mm radius. So taking again O as the center, we need to draw the prime circle of radius 35 mm. Once that has been done, the cam shaft has to be drawn, as in the problem they mentioned 40 mm dia. So we need to draw the cam shaft. This is a cam shaft circle. Now as in this particular problem they have mentioned offset is by 12.5 mm. So again we O as center and 12.5 mm diameter, draw a circle. A radius of 12.5 mm, draw a circle with again O as a center. Now from again O is we call as the offset circle. Again O is the center, you measure towards right 12.5 mm and draw a dotted vertical line such that it passes to the prime circle at point A. Now join OA. That means the roller is offset by 12.5 and the roller will start moving from follower will start moving from point A. Now once that has been done, next we need to transfer the outstroke, dwell, return stroke and dwell as mentioned in the problem here, the values. So taking OA as the base, mark 120 degree, that is the outstroke, then 45 degree dwell, again 150 degree, that is the return stroke, and remaining of course is the again 45 degree is the dwell. Now divide outstroke and the return stroke into again equal number of even parts, as same as that we have done in the displacement diagram, that is 6. Mark all the points on the prime circle, mark all the points, the points x 1 2 3 4 5 6 and 0 1 dash 2 dash and so on. After marking the points, draw the lines such that it is tangent to the offset circle. That we should always remember. So whenever there is an offset, the lines that we draw, it will always be tangential to the offset circle. Draw the tangent lines and draw the tangent line from such that it goes beyond the prime circle. These lines goes beyond the prime circle. Now after that, as we have done in all the problems, we need to transfer the values from the displacement diagram to the profile of the cam. So in the displacement diagram, measure 1b using a compass, come back to the profile. Here take 1 as the center and cut a arc and mark it as B. Again go back to the displacement diagram, measure 2c there, come back to the profile of the cam, take 2 as the center and again cut an arc on this line such that we mark it as C. Same way we have transferred all the values from the displacement diagram to the profile of the cam. So here hence we mark it as D, E, F, G up to P. Now once that has been done, join all these arcs with the points, that is B, C, D, E up to P. Join all this with a dotted smooth curve, and this dotted smooth curve will extend up to the prime circle. So this dotted smooth curve is what we call as the pitch curve. We call it as the pitch curve, and we have already defined what a pitch curve is. It is actually, when we say pitch curve, it is the curve generated by the trace point as the follower moves relative to the cam. Okay, it is a trace point. So that the follower, when the follower moves relative to the cam, and we should always remember, for a knife edge follower, the pitch curve and the cam profile are the same, whereas for the roller they are separated by the radius of the roller. So that after drawing the pitch curve, take B, C, D again as the center and draw rollers, that is circles, and this roller diameter will be 20 mm as given in the problem. Take B as the center, draw rollers throughout the points. Once the rollers has been drawn, join the bottom of these rollers. Join the bottom of all the rollers that has been drawn with so that we get a smooth curve, and join it to the base circle. Join it to the base circle. Now this is the profile of cam. So that completes the displacement as profile of the cam. Now coming to the next problem, problem number 13. Here is mention given, draw the profile of a cam operating a knife edge follower when the axis in the bracket they are given, when the axis of the follower passes through the axis of camshaft from the following data. Follower to move outward through 30 mm with simple harmonic motion during 120 degree of cam rotation. Follower to dwell for the next 60 degree. Follower to return to its original position with uniform velocity during 90 degree of cam rotation. Follower to dwell for the rest of the cam rotation. The least radius of cam is 20 mm and the cam rotates at 240 rpm. So this is what has been given. Now let us intercept this problem. Clearly mentioned in the first line of the problem, that is the cam is operating a knife edge follower. So the type of follower here it will be knife edge, and they also mentioned that the axis of the follower passes through the axis of camshaft. That means they are in line. The axis of the follower and the axis of the cam are in line, and they have given this following data. Follower to move outward. When we say to move outward, means it is the outward stroke through 30 mm. Here 30 mm is the lift, that is S, and here the outstroke will be performed using simple harmonic motion. It will be done is the simple harmonic motion, and the degree of rotation, cam rotation is 120 degree. After that there is a dwell for 60 degree. Then the follower to return, that is the return stroke to its original position with uniform velocity. So here again the follower follows two motion, simple harmonic motion during outstroke and uniform velocity during return stroke. Next they are given there's a dwell for the rest of the cam rotation, and they are given the least radius of cam. Here the least radius of cam is 20 mm. So when we say least radius of the cam, it means the base circle radius is 20 mm and the cam rotates as 240 rpm. So this is what parameters they are given. So let us see how to draw the displacement diagram and cam profile. So first write down the data that has been mentioned. We'll write it down. Now the first thing we have to do is draw a horizontal line, and this horizontal line will represent the outstroke 120 degree, dwell 60 degree, and again the return stroke of 90 degree. And the scale, of course, this has to be drawn according to a given scale. You take some suitable scale. Now once it has been drawn, mark the outstroke, dwell, and the return stroke. And as next step is we need to divide the outstroke and the return stroke into equal number of even parts. So here in the sketch it is 6. It has been divided into 6 equal parts. Next, through this 6 equal parts points that we have marked, divided, draw vertical lines. Draw vertical lines. These vertical lines height will be equal to S, that is the outstroke stroke of the fall, that is lift, that is 30 mm. Then we complete the rectangle box. After that we draw the displacement diagram for the outstroke. So here in the problem is clearly mentioned the outstroke, the follower moves with simple harmonic motion. So whenever we have simple harmonic motion, we need to draw a semicircle and then divide the semicircle again into equal number of even parts, same as that of outstroke or return stroke. Name it. After that, draw horizontal lines from the semicircle where we are divided to 6 parts. Here you can see here the first line intersects the vertical line 1 at A, second line horizontal line intersects the vertical line 2 at B, and so it intersects at remaining lines intersects the vertical line at C, D, E, and F. Now join all these points with a smooth curve. So this completes the displacement diagram for the outstroke. Next is the dwell, a straight line. Next displacement diagram is for the return stroke, and they clearly mention during the return stroke the follower follows uniform velocity motion. It follows uniform velocity motion. Since the follower moves with uniform velocity during his return stroke, the slope of the displacement will be a constant. It won't vary. The slope will not vary. Hence, in other words, we can say that it will be a straight line as shown. They just draw a straight line from G to M. So this completes the displacement diagram for return stroke. So this is the complete displacement diagram for outstroke as well as return stroke when the follower moves with simple harmonic motion and uniform velocity motion respectively. Once displacement diagram has been drawn, next we will draw the profile of the cam. So as first mark take O as the center and draw the base circle, and the problem they mention the base circle diameter as 20 mm. So we mark the 20 mm. Now with, and it's clearly mentioned the problem again that the follower and the cam shaft axes are same. That means they are in line. So we just draw a vertical line, such that it intersects the base circle at O here. Okay. Now with O dash and O as the base, we mark the outstroke, that is 120 degree, dwell 60 degree, and again the return stroke 90 degree. After marking the angles, divide the outstroke and return stroke into equal number of even parts as that of displacement diagram, that is 6. Mark it as 1 2 3 4 5 6, so on. Now with again O dash as center, draw lines through 1 2 3 4 5 6 and so on, and we should make sure that whatever the lines we are drawing through 1 2 3, it goes beyond the base circle. The lines goes beyond the base circle. Now once this has been drawn, we need to go back to the displacement diagram. In the displacement diagram, measure 1a, use a compass, come back to the profile of the cam, take 1 as the center and cut an arc to the line of 1 and mark it as A. Same way, go back to the displacement diagram, measure 2b, come back to the profile of the cam, take 2 as the center and on this line cut an arc B. Same way we mark all the points A, B, C, D, E, F up to M. Once it has been marked, arc has been transfer all the values from displacement diagram to profile. Join all the points A, B, C, D, F up to M by using a smooth curve as shown, and join it to the base circle. So this completes the profile of the cam. So this is the profile of the cam to be drawn. Displacement and this profile of cam, this is how it has to be drawn. And here again we should take care. Here the type of follower is knife edge, and we know that for a knife edge we don't get the pitch curve because the pitch curve, that is the pitch curve, knife edge is here, the pitch curve and the cam profile are same, it's a knife edge, but not so in the case of rollover and flat faced follower, as we have seen in earlier problems. So this completes the profile of the cam. So today's session will stop here. In the next section we'll see a few more problems related to CAMS, where the follower motion is a combination of two motions. Okay, thank you.